Welcome to a new test and teardown video. This time it's a Philips oscilloscope PM3266. This scope is from 1980. It's quite heavy and quite large, 11.4 kilos. Look, it's touching my wall in there. And this is the kind of space I got left for my experiments, and my table is 80 centimeters deep, which is really deep. Oh, that is of course how it was in the good old days. I don't know if you can see this. It says rise time 3.5 nanoseconds. So it's a very fast oscilloscope. In the good old days, some of the Philips scopes, I think actually quite a lot of them, they only use the rise time to tell you how fast the scope is on the scope. Of course, it's written in the manual. This is a 100 megahertz scope at -3 dB. There are a few special features on this scope. First, of course, it's 2 channels, and we got 2 individual time bases with their own trick. So you can even take a main time base, and then you have a trigger, and then you can have your delayed time base using another trigger level, and you can trick on another trigger source. I think that is a little bit special. We got a few problems with this scope. First problem is channel B here is a little bit unstable. As you can probably see, it's a little bit jumpy. I was playing a little bit with this scope yesterday, and all this got nice and stable. But when it got stable, I was losing, I don't know, 10-20% of the level on channel B. But right now I have exactly the right level. So now it's going between the two bats. So I think this is, I just had it in the low level, and then it was kind of stable. So I'm going to figure out if it is a mechanical thing, because everything I poke around with here, I can't get this. No, I can't get it away on channel B. No. Oh, there's another feature I forgot to tell you guys about. This scope got analog storage. At the moment, all the storage features there are off when you click in those two. So that is memory off. But as you see a lot of the time with these old analog storage scopes, the storage features don't really last as long as the rest of the scope. And there's a lot of good reasons for that, by the way. It's in the nature of how the CRT is made and how it's working with all the different layers of phosphor and light sensitive coatings on the phosphor and all that kind of stuff, and the flood guns and all that. But the flood guns actually works. See, plenty of flooding. And then you have the adjustments for how bright you want this to be. And then you have here, you can go and see the writing, and see again. There is just no way to kind of crank down intensity here. That will also affect how much you are storing. But you see, I can't really make it. It's quite difficult to show you. But this is definitely not working good at all. I will of course check the flood voltages and see if there is an electrical explanation for this. but I honestly think that we are talking about the phosphor coating that has just been used way too much. Let's try and play a little bit with the time bases. So now we're using main time base, as you can see here, right? We can also just go straight to the delay time base and then try and play with the trigger. So here we are now triggering on the A signal, like that. Isn't that funny? So we can go alternating, and now we see both the main time base and the delay time base. Look at that at the same time. And what I think is really, really funny is, look at that. So depending on where my trigger is here, see, and the other trigger is that one. Isn't that a little bit cool? And this is, of course, the delay. Can we get, yes, we can get a little bit more, depending on how you're playing with it, right? And then we have a trace separation, where I can move the two traces individually. Obviously, if I dial here, this channel is gonna move, or that channel is gonna move. Not a big surprise here, right? You still see channel B go a little bit jumpy here. I try to push it a little bit. You know, I don't want to shake stuff like this so much because it could prevent me from finding the bug. So what I will do now is open it and see if I can figure out where is this problem. There's actually a few other little problems I would like to show you. Let's go back to Timebase here. Let's show just one channel like that, right? So here is the position. I don't know if this is visible to you, but can you see? Can you see there's a line there? Let me play with it. Yes. Oh, look at that. So the intensity is, of course, for the trace, right? But when you dial down the trace, there's this line here to the left. And if I go, we are now in auto trig, but if I go in normal trig mode, it's of course responding to the incoming signal. So there is a signal. If I remove the incoming signal, and look at that. So the sweep is now waiting for a signal, and you have this dot. So, and this is not affected by intensity because this is the brightness level. So I believe somebody's been poking around inside this scope in the brightness control. So that will be the CRT board. So that one is not supposed to be visible at all. And this also tells me that there's something going on with intensity. And the reason why I know that is when I was in the dual time-based mode. Let me show you this. Should be able to play with that again. Here we go. See, when you go here, you should be able to play with the brightnesses and see that the selected brightness of that one is visible. Where is it on the other trace? As you can imagine, it goes a little bit brighter right there, and so it is. That will be the part that we are zooming in on, right? I don't know if. So now it's this little tiny bit there, and by moving the delay, I will move it. I don't know. Can you see that? But it is almost not visible, and that there should be a very big difference in brightness. when you're using delayed zoom indication like this. So that reveals something is going on, and that could also potentially be the reason for storage not working. Let's look a little bit inside this fantastic Philips oscilloscope. First, we're gonna look at the bottom of the unit. So this will be the trigger inputs and all that kind of stuff, right? Channel A and B, and the first amplifier is in here, and then channel A and B goes in coax cables to the intermediate amplifier. This amplifier here is also what handles the chop alternating mode, and then the output driver to the delay line. So those two cables goes down here into the delay line, right? Here is the storage logic. This is where you select enable and disable and what kind of storage modes you want. Let's go here a little bit on the back. This is of course the on-off and the brightness potentiometer, and a switch is integrated in here. This board here is doing brightness and all the different dimming of beam return, focusing as well. It's doing quite a lot of stuff. So I guess I want to go and clean the trimmers here and see that all that is good. We got a lot of high voltages going on here. That will of course be to all the different focusing systems and the brightness systems, and obviously the brightness potentiometer goes here in to this system here. Inside here in the middle of the unit, we got the mains power supply that delivers all the different voltages. That one works, and it's exactly like all the other Philips power supplies I have already shown you a lot of, so I don't really plan to go in there and have a look really. Well, we got two different high voltages coming out of the main transformer. So we got a few kilovolts going here to the tripler, and the tripler makes plus 7 kilovolt for the main beam anode. And then we got I think it is 1 or 1.5 kilovolt that goes to the cathode and all the focusing voltages, and the cathode runs at minus 3 kilovolt, and that means brightness grids and all that kind of stuff, it will be down in this area as well. This power supply here is creating all the different voltages for storage. And we've got some little relays here that turns on and off the different voltages for storage. So you should hear those relays go click click when you play around with the different modes of operation. Here is the block diagram for the entire unit, and let's zoom directly into the CRT section in the upper right corner. Here we find the set amplifier and the focus part, and this is of course what I need to look a little bit deeper into. We also see the storage amplifier and all the different signals that goes to the CRT. So the storage beam or the storage system in this CRT consists of different meshes and colliminators and all sorts of special grids and those flooding beams, and all those things needs to be perfectly adjusted and aligned to work. And this is of course something that I will look deeper into. Oh, I forgot to show you this. Look at all this corrosion here. And I'm so afraid all this is going to go down into the boards and stuff. I've been rotating this unit on the table a few times, and I don't know if you can see this, but my table is full of little white aluminium corrosion kind of dust. So I think I will take a little screwdriver and go outside and scrape everything that is loose away. This was probably stored somewhere with high humidity or in a wet shed or something like that, because you can see quite a lot of corrosion here. So this is not how you want to store old vintage electronics. And it's also on the front aluminium frame here. You see corrosion here. You can imagine this is not good if this goes into all your circuit boards. Let's have a little look at the top side of the unit. By the way, this fantastic storage tube is completely transparent. I don't know if you can see it from here, but yes, you can see all the way through. So there isn't the classic anode resistor coating or anything like that in here. It's completely transparent, so that's really nice. That will be all the connection points for all the different flooding grids and all that kind of stuff. That is the flood guns and the storage system. And that is, of course, the anode connection that is carefully isolated. That will be the storage amplifier. See, I wrote a little bit down here so we can easily figure out what is going on when we are playing around with this stuff. So here is the 500 volts coming in from the power supply. I want to measure, and that voltage is perfectly correct. Here we've got all the different transistors that's enabling and handling all the different storage voltages. As you can see here, this goes directly to the CRT. And oh yeah, we got MOS circuits. So that means they're static sensitive. We've got a lot of trimmers where you can set how much erase and how much storage and all those kinds of things. And we've got, of course, the trigger amplifier. And that will get some signals from the inputs, and then it will do all the different triggering. Timebase is that board here. And that one is the horizontal or X amplifier. This one is not running as fast and as crazy fast as the vertical amplifier is right here. And that is the delay line in here. The balanced delay line where wires goes back and forward 1,000,000 times to make a very, very long wire. I don't know if you can see how big this scope really is, but that CRT is definitely what sets the size of this scope, because the CRT sticks out a little bit on the back even. See, there's a little plastic stick out thing here for the connector. So that is definitely why it is that deep. The fun thing is that the power supply that you access from the back only goes to about here, and then the rest of all this in here is completely hollow. There isn't anything in there, by the way, as you can see here, right? One thing that I always do when I'm playing around inside units like this, then I look for the chip with the highest number of the date code. So that is 82. So that one tells me the age of this product, right? But sometimes it's also a little bit fun to find the oldest chip on the board. And look at that one. 1977 for that one. So they had this one in stock for quite some years before they manufactured the board here. They're just buying in a very high number of these chips, right? So that's a little bit interesting. I think I got good news. So the channel A and B differences and the unstable and all that kind of stuff, it all comes down to the position potentiometers and the gain adjustments. Those are, as you can see, a little bit dodgy. So this is the channel B and A. They are now on top of each other like that, right? But if I just wait a little bit, then the position here kind of moves. So there is some little things with this. The more I use them, the better it gets. As you can see here, we got the two beams exactly perfectly aligned. So it is of course possible. Now it's perfectly calibrated, and I think it's also probably this switch here, but I think this is, yeah, you just need to use it a little bit more. So now I will go on and see if I can play with the brightness, and there's a little funny things here, but other than that, it's quite nice scope so far. I'm happy that this is nice and stable now. I've been working a lot with those trimmers, and look at that. Yeah, I'm sorry the picture is upside down, but you get the point. This is because now I can access the different trimmers in the brightness section. Let me zoom out a little bit here so you can see what I'm doing. So this is the main Timebase. Let's take delay Timebase. Is that, see? And now we can poke around here, like delay Timebase and alternating. So look at that. It is now, see? I don't know, this camera isn't really showing exactly how nice it is now with the different brightnesses. So when you're moving around with your delay, you see exactly what is going on. Nice and smooth. And also the beginning of the beam is also solved. Let's remove the auto trigger and then move. See, there is nothing here. I'm trying to move the picture. Here's the start of the picture, remember? Remember I had some dots and they're gone as well. And it all comes down to somebody poked around in those trimmers here. So this is the trimmer right here that is doing the relationship between the blanked brightness and the non-blanked brightness, and that now is correctly adjusted, and now the brightness here is working correctly so that you can make a nice difference between the different brightnesses for delay and not delay and all that kind of stuff. So it's really working now. Fantastic. I still have some problems with the storage and storage levels and all that kind of stuff that is not working. I don't think it has something to do with all the cracked capacitors. Let me turn the light on here. So all those capacitors here I have marked for later, because I think we need to replace some of those. They're cracked all the way around one of the sides, so there's probably getting all sorts of humidity in there, and they're probably not really working or leaking or something like that. But other than that, all the voltages and all that kind of stuff for all the storage is correct. So the reason for the storage not working, as I've shown very early in the video, I think that has something to do with the CRT itself. So that is just worn down the storage. So that is just how it's supposed to be. I mean, sorry about that, but it's still a really nice, super fast scope. Oh, you are not going to believe it. Remember I was complaining about the storage? It's of course not perfect, but there was a trimmer that was not working in the storage section, and the voltage just seems to be all right, but it was a relationship between some of the voltages. It's working now. Look at that. So here's the right. It is a little bit difficult to capture this on the camera, but there is a nice shaped curve here, and then I go to the storage, and now you see the stored curve. Of course you still see some ghosting and all that kind of stuff. But it is what it is. See, now it's not responding. So now I've moved both of the curves a little bit, and let's go again. Right, and here's the new. So yes, it is definitely storing on the CRT. Haha, great. So here's the right, you see? And here's the stored image. Oh, that was really, really good. Look at that stored image. Wow. So I think we are done playing with this oscilloscope. Everything now works. Storage works. Yeah, as you can see, XY mode also works. Maybe we can even store the... okay, that is not looking so good. But anyway, thank you very much for watching, and please come again soon. Bye bye.